This lesson is on graphing linear inequalities. And the first thing we want to talk about is when we are getting ready to graph, you need to know what kind of line to make and what kind of shading that you will need. And you get this by looking at the symbol and how it is in relationship to the y. The ones that are strictly less than or greater than, these two, have dotted lines. If it has a less than or equal to or a greater than or equal to, thinking it has that solid line underneath, those lines will be graphed solid. Okay? And then if it is a less than symbol in relationship to the y, like the first one or the third one, you are shading below. If it is a greater than symbol, like this one or this one, you are going to shade above. So if you need to, write this down and you can refer to it later. If you need to pause to write that down, do it. But otherwise, maybe somebody will just remember that less than or greater than strictly are dotted lines. Less than or equal to, greater than or equal to are solid lines. If it's less than, you're shading below, and if it's greater than, you're shading above. Now, the question sometimes comes up, what is below and what is above? Well, if you have a line, think about standing on it. If you were the person trying to stand on that line, that is above. If you were standing on that and you would be hanging off the earth, then you are below. So shading above and below kind of works like standing on a hill or hanging off of a cliff. For our first example, we're going to graph something that's already in slope-intercept form. We can identify that our y-intercept is 3. And so that means that on my y-axis, I'm going to be at 3. And then the slope is the number that's in front of x. So there's an imaginary 1 there. And so that means that my slope, I'm going to think of as up 1 and over 1. So from the point I just drew, I'm going to go up 1 and over 1. And then I want to connect those using a dotted line because this is a strictly less than symbol. And it's kind of hard for me to draw straight on here. You can probably draw straighter on your paper with a ruler. So I have a dotted line. And then because it is less than, I'm shading below, which is underneath this line. So this whole area is shaded. Now, the thing about this is, what does that mean? That means that any point that you pick in this area actually satisfies this equation. So, for example, if I picked 4, 0, this point right here, 4, 0, if I plug those numbers in, that equation should make sense. So, if I plug 0 in for y, less than 4 plus 3, put that 4 in for the x. Obviously, 0 is less than 7, and so this makes sense. So any point that you pick in this shaded area should make sense in this graph. Equation should make sense in the equation. Now, our second example is not in y equals mx plus b form, slope-intercept form. This is in standard form. And so I'm going to need to get that y by itself first. So I'm going to subtract the 3x, and I'm going to have 4y greater than or equal to negative 3x plus 12. And then I need to divide by 4. So divide by 4 everywhere. I get y greater than or equal to negative 3/4 x plus 3. So again, I'm going to come over here and I'm going to say my y-intercept is 3. So I go to 3 on my y-axis. Then my slope is negative 3/4, so I'm going to go down 3 and right 4. So down 1, 2, 3, right 1, 2, 3, 4, and end up at 4, 0. This time I have a line underneath my symbol, so I should be doing a solid line. And again, I would use a ruler on here. I can't do that. And then I have to decide about my shading. Since it's y greater than, I'm going to be shading above. So that would be where I could stand on the hill. That would be this side. And again, every point in this shaded region should make sense in that equation. So if you need to test a point to see if you've shaded right, that would be a good idea. And if you need to pause and take a minute to write this down, please do so. For our next example, it looks kind of funny because we have just x greater than greater than -3. And so what that means is this is going to be a vertical line. Anytime it's x and a number, it is a vertical line. So you go to where x equals -3, which is right here, and we're going to do a vertical line. It's going to be dotted because of our symbol. So all along there, dotted. And then it is x greater than. Well, you have to think, where are x's bigger than -3? The left side or the right side? And in this case, it's the right side. So you shade all over here. And obviously, any point that you pick in this area is going to have an x value that's greater than -3. And so that completes that graph. Since we've done an example with an x and a number, I'm going to do one with a y and a number. And so in this case, we have y less than or equal to 4. Y is where you have a horizontal line. Okay, x is a vertical line, y is a horizontal line when there's no x's in this. So we go to where y equals 4, and we do a horizontal line there. And this one is going to be solid. So solid horizontal line. And this is shade below. So I'm going to shade everything below that line. And that's how that one works. So x is a vertical line, y equals a horizontal line when it's just a number. The next couple that I do are good ones if you want to pause and try them on your own. If not, you can just keep watching and I'll obviously explain them. But if you want to, pause and see if you know what to do. Number 5 is in standard form, so I need to get the y by itself. So I need to subtract x. So I have y less than or equal to, I should do -x plus 4, because that's how we look at the slope. So to make that a little more clear, -x plus 4. And my y-intercept is the 4. A slope is a -1. So you have to think of it as -1 over 1. So I'm going to go to 4 on my y-axis, and then I'm going to go down 1, right 1 to get that slope right. This is a solid line underneath, so solid line for my picture. And then I'm going to shade below because it's y less than. So again, if you did this on your own, hopefully you got it right. You can check it, see what you did wrong, and move on to the next problem. Okay, this is our last example, and again, you can pause and try this one on your own, or you can listen. This one does have a tiny little bit of a something that you have to remember about inequalities with it. Okay, so as we answer this problem, again, I'm in standard form, so I need to subtract the x and get -y greater than or equal to -x plus 2. So I moved it to the other side. Now, this one is different because I have this -y, and that means I need to divide everything by -1. When you are doing inequalities and you have to divide by a negative, that means you have to flip the sign. So as soon as I realize I have to divide by a negative, instead of being a greater than sign, I'm going to change to being a less than sign. Then on this side, the two negatives cancel and I just have my y. Here, the two negatives cancel and I just have x. But then 2 over -1 is now -2. So this equation became y less than or equal to x minus 2. And this is the one I need to pay attention to when graphing. So my y-intercept is now -2. You look at the whole thing. So I'm crossing down here. And I have an imaginary 1, so my slope is up 1 over 1. So up 1, right 1. And this one is a solid line. And I'm shading below because of the less than sign. Now, please be careful on these, because if you had looked at that original problem and had not gotten the y by itself, you may have thought that it would be greater than and you would be shading on top. You have to get the y by itself. You have to flip the sign when you divide by a negative.
or you will get your shading wrong. Okay, you might get your line right, but you will get your shading wrong. So make sure that you're paying attention to those details. And that concludes this lesson.